We're not going to give you a magic bullet here today. We're not going to say, do this and your computer will be really, really fast, because the reasons that things get slow are wide and various based on a lot of pieces and parts. But one of the things that really comes to mind when we talk to people is, when we talk about the computer being slow, that is a very, very simplistic statement. In a lot of cases, there's one part of it that's the bottleneck. One component where if we just took care of that, it would actually speed things up significantly. So the key thing becomes, how easy is it to identify what that bottleneck is? And where would it be and all that kind of thing. And that's kind of what we're going to be talking about. And that's why I said to Kevin, oh, Kevin. Cool. So when it comes time to actually talking about technical and real things, I'll be asking Kevin to actually say things accurately. One of the first things to understand is, where is the work being done? Because the whole part of having a slow computer is something isn't processing things properly or in an accurate, in a timely manner and all that fun stuff. And unfortunately, as we move forward, where the work's actually being done is changing constantly. So it used to be, we had local. If we're just doing word processing, we're just doing an Excel worksheet or the like, the data, the programs, the user interface, all of that stuff is right there in the computer. There's no connectivity, there's no nothing. So the question is, why is this computer literally so slow? Then we've got local network applications. That's usually where there's a program or data on another device, usually a server, that's within your facility. In which case, now you've got two parties that are responsible, the server and the workstation, plus whatever the connection is between them. Okay, so now we went from one party involved to three parties involved. Web-based. That's where the actual program and the data is all up in the cloud. What's the cloud? Not here. All right? So there's still a server involved, but now we've got not only the connection of this laptop through this network, now we're going up to the cloud and we're going up to resources and servers. So now we've gone to 4 pieces parts, possibly more. And then finally, hybrid. We could have some kind of application that actually uses components from all of these together. If you'll notice, there's a complexity building. Now, to the end user, there isn't. Because it's still, they bring up a screen, they do things, and things should happen as a result. But when we start talking about how do we evaluate the bottlenecks, how do we evaluate the speed of the system, it gets more and more complicated. Anybody remember Rube Goldberg? Okay, one of the first network designers. The guy was turn of the century, right around 19-teens, I believe, where he would draw these diagrams. And in this particular case, it's how do you remind this guy to post the letter that his wife gave to him? Very simply, when he walks towards it, there's a hook here. When he walks by the hook, or when he walks by this, the boot will be kicked by this hook, which will cause the football to go into here, which will cause this to go down. This will then pour water on a suit coat, dragging it down, which will unleash the bird. The bird walks out, eats the worm, pulls on the worm, which will draw down a little sign that says post the mail right by the mailbox. Okay? That's a network. Because we've got this desktop over here that's actually connected to the internet using DNS to resolve the name. Once it resolves the name, it then connects to the server, goes through the security, does a request for the data, it authenticates and authorizes the data. The data is then pulled out, the data is then transmitted. And then it comes all the way back again to the workstation, and then goes all the way back again for everything you do. And guess what? Every one of these pieces was done by a different vendor. All right? And every one of these could be actually having 50, 100, 1,000, 5,000 people all trying to get to these resources at the same time. I'm amazed it works. Period. Okay? So, actually, hold on. One of the other things I want to bring up is it's a term that was brought into play about 6 or 7 years ago by Microsoft. And I think it's a great term and we don't use it enough. And that's user experience. Okay? We used to talk about user interface. User interface is essentially the thing that the user uses in order to get their job done. Okay? It's this entry screen, it's this command set, it's this whatever. About 2005 or so, I think Microsoft started using a term. It's not a Microsoft term per se, but it was the one, it's where I first started using it or hearing it. Instead, use the term user experience. And the user experience term is essentially how the experience was for them to do whatever the heck it was they were trying to do. So, was there a lot of learning curve necessary for them? Were they able to effectively and quickly do whatever the heck it was they were trying to do? And you'll notice, we could be talking about playing the game solitaire. What's the user experience? If they had to build a deck of cards every time they would play, that'd be a lousy user experience. You know, similarly, if you're trying to get something specific done. So the user experience, and the two best examples I've heard on this, would be if you're walking in a mall and you walk up to a kiosk, and the kiosk is there so you can see what stores are there in the mall. Does anyone still go to a mall? So you can find whatever store you're particularly looking for and possibly get information on that store or even a coupon of some kind. And that has to be almost no learning curve. You have to be able to intuitively know, you have to be able to push this, get this information, get the coupon. Speed is of the essence, low learning time, low learning curve is the, you know, it's gotta be very, very quick. Okay, cool. Now let's take a fighter pilot. There is not going to be, when they sit in the cockpit, a fly, land, shoot down bad guy. 3 buttons, push those 3 buttons, life is good. No, it's an extremely complicated interface. It's a very complicated learning curve, but the user experience is, did he or she, the pilot, get their job done quickly and efficiently? If they did, the user experience is still a good experience. Okay? So keep that in mind, especially when we start talking about performance and all that fun stuff. One of the things that we're going to talk about the resources, but one of the things that really gets in the way is the bottleneck. And the bottleneck is essentially where there's a resource that's required and we don't have enough of the resource for the demand. We've all experienced it, especially if you have kids, you know, where there's multiple demands on that resource, but we can't, you know, 5-pound bag, 10 pounds of gibbity-wop. And in a lot of cases, if we break down the resources that are required for the computer, we can find there's a queue building for one of those resources. Memory being probably the best poster child for that. So someone would sit back and say, my computer is posed, I need to get a new one. When in fact, it's just we're running out of memory. Or we need to reinstall Windows because everything is slow. Maybe running out of memory. Or some other bottleneck. We'll talk about those. So when you start getting a queue on any of these resources, in a lot of cases, it slows everything else down because everything is waiting for that particular resource to actually perform whatever task it needs to perform. So when we talk about a computer, and by the way, for the most part, this is non-vendor specific. So you want to talk about Macs or even Linux, Unix boxes, pretty much goes the same way. Okay. So what kind of components are we talking about? We're talking about the processor, the brain, if you will. That's the thing that's actually performing the tasks that are being asked, running the program, if you will. And by the way, for you geeks out there, yes, I know I'm simplifying big time. Okay? And by the way, we're also talking about primarily desktops, laptops, tablets, or the like. But for the most part, this can be used to discuss servers as well. Although with servers, there's a whole different level of components for this. So, and we go back to these 4 types of activities. So if we're just talking about local, really the PC is all that matters because there's nothing else going on. There's no other external component involved with that. So we've got the processor, the brain that actually does the calculations and does the execution of the code. We then have the memory, or as I refer to it, the scratch paper that it's using while it's executing these things. Then we have the disk drives, which are the physical devices that are storing permanently the data. And then we have the network card when we start talking about, now we're talking about getting into the external world. And then we've got the switch. The switch can be, you can talk about switch, hubs, routers, any of that kind of stuff. And then if we go outside of this facility, what's your internet connection like? And then finally, the provider. If we're talking about we're connecting to a server locally or we're connecting to a website out in the cloud, are they the bottleneck? Because they're overwhelmed. So we've got those. So when we start talking with the PC and the processor, again, the processor is the brain behind it, constantly changing, more powerful. The new ones are all 64-bit. What's 64-bit? It's twice the size of 32-bit. It's essentially how complex can the instructions be that you're asking it to run. And similarly, if I asked you, and I only gave you the ability to give me instructions using this many letters, or I doubled that, you could give me much more complicated instructions. Right? The same kind of thing. Okay? Whatever the number, more is better. There's two ways that, and you'll hear about core or multiple CPUs. You can actually have cores which are multiple brains but still inside of one chipset, or you can have multiple chipsets. But any way you slice it, you get the number of the actual chipsets versus, or times the number of cores. That's how many brains you can have working on this simultaneously. More is better. Okay? So a lot of you will hear dual core, that kind of thing.
I will say, on the more is better, it's not totally true. If you look at computers 7, 8 years ago, you had your 2 gigahertz, 3 gigahertz processor. Well, right now, you have the same 2 and 3 gigahertz processor, but they're totally different families of processors. It's saying you can't compare that speed number for an actual performance indicator. So your 2 gigahertz processor from 7 years ago is nothing compared to a brand new 3rd generation i7 2 gigahertz processor. So there are plenty of websites out there that will actually quantify that number, like the performance between them, but just comparing the front 2 and 2 is not, it's not a good way to go.
And that also brings up a good point, because you'll see all sorts of stuff about Intel chipsets versus AMD versus this versus that. It's confusing, and unfortunately or fortunately, it is constantly changing. Now, the topic is not how to evaluate new hardware, so we're not going to get into that too much. But by and large, kind of like Kevin once said, newer is better and stronger and all that kind of fun stuff, by and large. So, memory. That's what we're using to execute the program. So by having memory, again, the way I look at it is scratch paper, if you will. The other metaphor that I'll use is a table. So if a person is working on a desk or is working here, they can spread out as much information as they can and work on it as will fit on the table. And they can do so very quickly because they're working on it right there. If they run out of space on the table, then they can't add any more until they take stuff off of that table and free space up, which is slow. And we'll talk a little bit more about that metaphor. And the problem, yeah.
When ordering RAM, is it best financially to max out the RAM when you order the equipment?
Really depends on what you're getting. There are some computers out there that can have a ridiculous amount of memory in them, and there's no sense in your average person buying that ridiculous amount. Should you go cheap? No, because this is usually one of the first bottlenecks you see. The first one being, or the other one being hard drive speed. That's always been a bottleneck on computers, but for generally speaking, anyone else, this is going to be your next bottleneck. And don't go cheap, but you don't have to go crazy.
But if you are ordering a machine and you are going to be needing RAM and there's a potential to upgrade, it's most financially feasible to max it out when you order it.
Yeah, you can add it later, but usually it just makes more sense to get it up front.
Okay.
Here's the fun part on questions like that. It's as much a financial question as it is a technical question. Because a year from now, 2 years from now, that memory is going to be cheaper. You know, and so if you're basically saying, you know, if you're budget conscious, you can get what you need right now with the idea that a year from now, 2 years from now, add another $100 or a couple $100 to it. So your mileage may vary. Okay. Also, this is electronic. The processor and the memory are electronic, which means that it's not quite speed of light, because it's electrons, not photons, but it's darn close to it. So the activity that's going on here between the CPU and the memory is extremely lightning fast. Okay, so keep that in mind. Okay, then disk drive. Like Kevin was saying, okay, now we're physical. We'll talk about SSDs. But literally what is happening with the disk drive is you have a set of what we'll call platters, which are round disks with magnetic material on them that spin at high speeds, and then there's a head that will literally read or write data, either read data or make changes to that. It's physical. When we talk about memory and processors, those are electrons moving around. This is actually gears and stuff going. It is orders of magnitude slower than memory. So if we have to do something with a disk because we ran out of memory, that's going to be a bottleneck, because we're going to have to wait for that disk to finish spinning around and reading and writing the data. Okay? You want to talk about speed or sort of disks go?
There's 4 different speeds for hard drives that are available out there. Your little devices, like the first generation iPods and whatnot, they had actually small hard drives in them. Those use 3,600 RPM hard drives. So basically, that little platter inside of it was spinning at about 3,600 times per second. Your traditional hard drive spins at about 5,400. Higher performance hard drives, 7,200. Servers, you start getting into the 10,000 and 15,000. And the highest you can get are the 15,000. And those are extremely expensive enterprise level drives. You won't see them in your computer at home, generally speaking. Most of your computers at home will have the 54, 72, and if people like spending money, 10,000.
And this is one of the reasons why when somebody says, if someone's talking about a server and say, hey, gee whiz, we ran out of space, and a lot of people immediately go, oh, let's just buy some more hard drives. I saw them at Best Buy for 75 bucks. When you talk about server, because you need that speed and you need the ability to take the pounding, it's a lot more expensive than that. So, SSD?
SSD, it's the newest trend with hard drives. You replace that physical spinning motor, you replace the platter, you replace the heads with all electronics. Effectively, it's a persistent version of RAM. So the previous slide where Bob had RAM, and you know that's how the computer does stuff. There's a newer version of that stuff that you can use for a hard drive. Obviously, this is again moving at the speed of an electron, and SSD drives are extremely quick and very power conscious. They use a lot less power in getting data compared to a traditional hard drive.
Any reliability?
The first generation of SSDs did have some reliability issues because what was happening is when you write data to a hard drive, you're physically changing the magnetic polarity of a small piece of that platter. Generally speaking, those platters can do that forever. An SSD, there was using an electronic component that would flip states between your 1 and a 0. Early generation SSDs can only do that for 10,000, 50,000 times. And after it did that 50,000 times, you can no longer use that particular bit on the hard drive. So that you lost storage capacity there. Hard drives would just keep moving on until it ran out of all of them. Newer generation SSDs really don't have that problem. I forget how many millions of cycles they can go through now, just because of the advancement in that technology.
to give you an example, I don't know how many of you heard last month when we were talking about Windows 8. So Windows 8, my tablet is an SSD drive. And it takes Windows 8 about 5 seconds to boot. Okay, and that's a complete Windows, and Windows 8 is faster than 7, but it's not that much faster. The SSD makes it powering up and powering down almost instantaneously.
Does anybody use SSDs in servers?
Oh, yeah.
Do they?
Absolutely.
And I just was worried about like lifespan and stuff like that, with like 3 years or 5 years or whatever they do.
It comes back to the,
15,000.
you know, how many cycles they can actually do. Because if you use SSDs, typically you see it on high access resources like SQL, where you have these massive databases, and you want your answer yesterday for whatever you're querying. I actually just looked at some SSDs for a server, and a 100 gig SSD drive was over $1,000. That was just for one of them. So they're not cheap, but they're designed to take that constant beating of, I'm looking for data, I need to write data, I need to delete data, I need to rewrite data. They're heavy duty things.
Good. Roughly 2 to 2.5 hours lead time between failures on SSD drives.
I would say on the first generation.
No, that's the enterprise class. 2.5 billion hours.
Oh, million. How is that work? You have to replace it fairly often. Okay, cool. Yeah, so they're getting to the point where they're approaching the same reliability rate of the regular drives. But this gives you a great example of, again, you go to Best Buy and you want a 2 terabyte drive. That's 2,000, gig, and hey, plop down 125 bucks. You want 100 gig solid state, almost 10 times that. But if they need the data that quickly, that's cool. Another thing that's happening a lot is you will have SANs, corporate storage devices, which will have layers. They'll have SSD drives, they'll then have high-speed traditional drives and the low-speed but higher volume traditional drives, and let the SAN actually figure out where stuff goes. So there's a lot of stuff going on there. Bottom line, though, is that if you have SSD, you're paying much more for it, but you're going to get a tremendous performance bump from that. So let's go back then to that analogy I was using earlier about the table, and now let's build some bookcases. And the bookcases are actually the hard drives. That's where we're storing the data and we're maintaining the data to be used. So when we run out of space here, which we can work lickety-split because we're right there and it's all electronic, if we have to go to that hard drive, we basically have to go physically look up by spinning the disk and moving it around, pull that data down, bring it into memory, and then continue going. And if we run out of memory, we start using the disk as kind of extra scratch paper, caching. Now we're actually going to be, okay, I'm not done with this, but let me put this over on the disk for a while so I can make room for this. I'll work on this for a while, and then I'll put this back over here, and then pull it. It gets really slow. So what's happening here? In this particular case, we've run out of memory, so there's a queue building as far as what needs to be put into RAM, into memory, and there's also the hard disk is doing all sorts of swapping back and forth. And it's not data that we're adding. This is just to keep us treading water. And every time we do that, we're building the queue of writing or reading to the disk. So we're building this whole backlog of work that we're trying to do with the computer. Okay?
Is there a performance penalty for an external drive over USB 2 or 3, 50, 400, or 7200 versus the internal hard drive?
Your internal hard drive connections are as fast as you're going to get. The exception being eSATA, which is a newer interface that will let you hook up an external drive. An eSATA hard drive will work just as fast outside of the computer as it will inside the computer. With your USB connections or FireWire connections, that's where your bottleneck is. Those particular protocols do not move data as fast as just traditional inside the computer connections.
And what percentage of performance? 2 or 3?
Let's put this probably, USB is about a third to a quarter as fast as.
USB 2?
Even USB 2.
Yeah.
USB 1 was.
Yeah, USB 1 is dog
100 or something.
Is there is USB 3 becoming more prevalent?
It's slowly picking up steam, and I will say USB 3 is just about, if not as fast as an internal hard drive connection. USB 3 is nice. I've got one drive that's USB 3 at home, and I can move data very quickly, which is very good considering it's a 3 terabyte drive. So I got a lot of data to move.
So you've got a USB 1, which is incredibly slow. All right. Older machines had USB 1 ports, and the fun part is they didn't always identify them. So you'd have a computer, an older computer that had both USB 1 and USB 2, and you literally didn't know which port was which. USB 2 is better than USB 1, but it's still slower than an internal, and USB 3 is, but the device has to be USB 3 compliant to take advantage of that. So if you have an older USB drive, it'll still work on a USB 3 connection, but you're not going to get the performance on it. Okay.
There's something new coming out called Thunderbolt that's actually faster than USB 3. That's, you can pretty much make it so you have a shell of a computer and you just carry your hard drive around. It will work that fast. It's something that the Macs have been putting out either as an option on the new ones, or I think it's HP or IBM that's going to start putting them on PCs.
Within a year?
Yeah, I actually think they're out for the Macs. I don't think there's too many devices that use it, but Thunderbolt's fast.
So it's a carry your whole hard drive with you.
Yeah, like say if you were going to a, well, I mean this is just theoretical, but can you imagine going to a lab someplace, or even to work? All of your computers at your work were just shells of computers. All they had were the processor, the memory, and a screen. And you would just carry around your hard drive, plug it in, and off you go. So, I mean, that's totally doable with Thunderbolt.
Is Thunderbolt a hard drive or is it
It's like USB. So you've got USB, you've got FireWire, now there's Thunderbolt.
Welcome to our world. The network card. Now we start getting funky. When we start talking about a network card, what we're doing is we're really connecting with resources outside of this device. Okay? So we're connecting to a printer, we're connecting to a server, we're connecting to something in the web, we're connecting to something else. Here's unfortunately where it kind of starts to get a little bit on the subjective side. First of all, internal connections are usually significantly faster than external as far as the building goes. So the connection that we can do within the building is faster than the connection we can get to outside the building. All right? And we've got wired versus wireless. Your mileage may vary on that one. But let's talk first of all wired. Wired is where you get the network cable and you plug it into the network card here. So you actually have a physical connection. By and large, those network cards come with 3 speeds. 10, 100, and 1,000 megabits per second. 1,000 is also referred to as a gigabit per second. That's the maximum that it can transfer speed, or transfer data. Now, for the most part, we're done with the 10s. For the most part, it's 100 or 1,000. And most cases these days, if you're buying a network card, is probably gigabit. I don't think anybody's selling hundreds.
Really?
But the device that you're connected to, which is the switch, which we'll talk about in a second, it also has to be able to talk gigabit. If it can't, it doesn't matter if your network card can't. So we've got that issue. Then there's wireless. Wireless is connecting to the environment through a single device, a wireless access point. And you can have multiples, but we'll talk about single for right now. Which if everybody's connecting to that device, if you have 20 people in this room and we're all connected with our wireless device, we're going to slow that puppy down. And depending upon what wire, and you get into this whole which protocol is it or whatever the term is, we'll do different speeds. If you want.
Oh, for wireless?
Yeah. We don't need to go into
There's four, and generally speaking, there's 4 used wireless protocols. And you might see the numbers 802.11 followed by a letter. 802.11 is the IEEE number name, or 802.11 is the IEEE number for wireless. 802.11a signifies a 5 gigahertz up to 22 megabit wireless protocol. 802.11.b is up to 12 megabit. 802.11g is up to 54 megabit, and 802.11n is 280, I think it is, something like that. It's some high number, but the way they actually calculate the number is kind of funny sales games, and you never really hit that speed, but that's the number you typically see associated with it.
So to compare it, remember we were talking about how most guys, if you connect it to a wire, you start with 100 and possibly up to 1,000 megabits per second, and you're the only one on that little section of wire. Whereas with wireless, you could go from 12 megabits up to maybe 54, up to 200, and your mileage will vary significantly. So as you can see, the wired, at best on wireless, you're still looking at twice as fast on the speed. With the best, you know, with the N, the N64, up to significantly, like 20 times. So if you can do a wired, you're going to have a better, experience.
Wireless can be distant too.
Absolutely.
Distance, environmental, equipment, there's about 1,000 factors dealing with wireless on what makes it fast or slow.
At the risk of exposing how incredibly dumb a question this is.
All right, everybody ready for a dumb question? Because there's one coming, I heard it. All right, here you go.
Okay. At home, I had a wireless network card on the back of my PC, and it had a little antenna guy on it.
Okay.
Computer helper friend managed to break that off when moving said computer. I have a router,
Okay.
and it is a G. It is an 802.11G.
Oh, gee, okay, cool.
G. So, can I take said network card over to Micro Center and say, get me a faster one of these, and I want one of those N?
Your router would have to be replaced,
Yes.
assuming it doesn't have that, and you would need to either verify your broken one can get a new antenna and will work with N, or just get a new one that will work with N.
I think I will get a new one.
Yeah,
But so once I'm on N on both, I'm cool.
Yeah, you should be.
And I can
stick
always
within
up-
manufacturers, because a lot of manufacturers like tacking on little extra things to the N protocol to do their own QoS and analysis and extra stuff. So if you stick within vendors, you'll be better off. Like if you buy a Linksys router, get a Linksys network card. Get a D-Link router, get a D-Link network card. The mixing can cause issues.
Thank you.
Because they both have special features.
I wasn't so stupid.
So if you upgrade one to like a higher ladder, and does everything have to be in the same ladder, or something backwards compatible?
Your mileage may vary.
N is technically can use both the 2.4 and 5 gigahertz channel, but it's not the same 5 gigahertz that A uses. A is its own little thing. Nothing else shares with it. B, G, and N can all use the same networks. For the longest time, actually, when N first came out, this was really bad what they did. The protocol was written in such a way that if you fired up a wireless N network and your neighbors all had G networks, your N network actually completely shut down all of your neighbors. It's called a bad neighbor, dirty neighbor. And yeah, they've since fixed that, but it's the way the N protocol works. It wasn't totally backwards compatible with everything else.
Well, yes.
Isn't A almost gone? I mean, if you see anything as limited A, should you just like throw it in the trash bin and
Well, you know, the nice thing about A is because it's not that used, those frequencies are pretty wide open. So yes, it's only a 22 meg connection, but you're pretty much going to be guaranteed that because everyone else is fighting on the B, G, and N networks.
Yes, and you never throw a piece of computer equipment away. It all goes to Dan Hansen and Computers Assisting People, and it gets recycled.
If I can add on to what Kevin was saying, if you'll notice, he started talking to Rube Goldberg. If you got A and B, the B will update the G and all that. If you buy it from the same vendor and the same tier, meaning around the same time and the same family line, it'll work. If you don't, it's going to be a fight between it should probably work and it might not. And the problem is that when it doesn't, you may run into situations where, oh, that vendor stopped supporting this, 802.11g when they introduced the N because they added this feature, et cetera, et cetera, et cetera. So what I would suggest is either A, in your instance, buy the same vendor, the same models, and all that kind of thing, or B, talk to somebody, hey, maybe, well, no, him, but talk to somebody before you make the purchases so that it makes sense. Part of the challenge on that is what I refer to as the geological dig. That's where somebody buys a piece of the hardware at one point in time, we'll say in 2010, and then they add stuff in 2011, 2012, and the vendor stops supporting it, they come out with the new, that's where life gets interesting. Usually there is some level of backwards compatibility.
Big part of the problem is IEEE takes so long to finalize the standard.
And the salespeople don't want to wait.
Selling their version of CAD. IEEE says, okay, now we finalize it, but we changed this setting. So now that thing only works within the family. But if you wait until after it's all finalized, then
that actually was a big problem with 802.11g when it first came out. G for the longest time was technically 802.11g draft. So it was never actually approved by IEEE. But every single wireless vendor out there had to get something out to the market so they could start selling stuff. So they picked this version of G draft, some of them picked this version of G draft, and you had all these different types of G equipment which may or may not talk to each other. And then a year or so later, G finalized at 22 meg and no one was happy.
Welcome to our world.
Yeah.